Swayam Prabha. Digital India. Educated India.
Welcome back to this class. We are going to make a little bit of a gear shift. Last time we were discussing integrated solid waste management and how to reduce the waste reaching the ground. We now enter into the core domain of landfilling, of placing the waste on the ground, and where we have to do a lot of design to ensure that the waste does not harm us all, or the people, or the habitat, or the animals, or the vegetation which is around the waste. So the next 50 minutes we will be discussing on principles of landfilling. So the underlying principle is minimize the waste reaching the landfills, and that is through integrated solid waste management. We have to close the tap. We have not to put a lot of buckets at the end of the overflowing bathtub to control the water. Scientific or engineered landfilling is basically placing the waste in such a manner that it does not harm the nearby environment. So minimize the waste which is still going to come, we place in a safe manner. If we have old waste dumps, then scientific or engineered rehabilitation or control of the waste dump implies adopt rehabilitation measures at the old waste dump to minimize or eliminate the harmful impact of the dump on the environment. Now please understand, the old waste dump has already impacted the environment in the past. Let's say a dump has been there for 10-15 years, it has already made an impact. But what would we like to do? First, we would like to ensure that it does not spread, the contamination does not spread. And finally, we would like to ensure that the waste dump or that land which is beneath the waste dump goes back to its original pristine state. That may be very, very difficult, but the immediate measure always is to contain the spread of contamination. We've done this before. When you place waste on the land, it becomes a part of the hydrological cycle. Precipitation, runoff, seepage through the waste, groundwater contamination, surface water contamination, the water evaporates, becomes clouds, precipitates again, and so all the time the waste is a part of the hydrological cycle. The waste is a source for contamination. The solids can cause the contamination, the liquids in the pore space of the waste can cause contamination, and the gases in the pore space can cause contamination. Pathways, precipitation, infiltration, seepage, the leachate will cause contamination. Surface runoff can cause contamination, which is passing partly through the waste or on top of the waste. Groundwater flow will be the pathway. The wind can carry the bad odor, the gases which are generated from a waste dump. The drains and streams can carry the surface runoff. Rodents and pests, which are much larger in numbers on waste dumps than the natural environment, they also become the pathways for contamination. And sometimes you'll find that on the top of the waste, we may put soil and then do vegetative growth on it. So if that vegetative growth or the grass becomes a part of the human consumptive cycle, that or the animal consumptive cycle, that also is a problem. The receptors are adjoining areas, people, animals, vegetation, the built and protected habitat. So we've done this before. The moment we put the waste on the ground, these are all the things that are happening. And our job is how to prevent this from happening. The most critical one is the issue about groundwater contamination, because everything else moves away. You have gas, you have odor. When the wind will come, it will take it away. You have contaminated surface water. When the monsoons will come, the river will get washed. But this just remains where it is. So let us say I have a site where this is the site, that's the water table at that site, and I am planning to put my waste here, which means I will excavate the soil so that I can make more capacity, and I will go above the ground level in placing the waste. So this is just a conceptual diagram. I want to place the waste in such a manner that it does not impact the groundwater table. So my immediate reaction is, why don't I put something impervious at the bottom of the waste? If I put something impervious, the leachate will not go into the groundwater. I have then isolated the groundwater from the leachate. But what happens? If the leachate can't go down, it will start accumulating inside the waste. And then what will happen? It will become full. Then what will happen? It will spill over. Because rain will keep on coming every year, and the leachate will keep on ponding up inside the waste. Doesn't look like a great solution. Well, then let's look at it philosophically. What next will you do? We'll say, let's prevent the rain from coming in. If we prevent the rain from coming in, great. You will not have more leachate. So all problem is solved. So I need something impervious at the bottom, and I need something impervious at the top. Do you envisage some problems? Let us see. Even if there is no rain, the waste is wet. It's food waste. It has liquids in it. So after some time, the liquid will squeeze out from the pores, because you have got normal stress acting on the waste, and this leachate will collect here. A little amount, pretty concentrated. Typically you can just see it as concentrated saline solution, because at least the salt will come out in it. And if it is this problem, we should not be bothered, because we have an impermeable liner at the bottom. But I've often given you this example that the roof that we make on top of us is only as impervious as the drain pipe which is operational. That means the roof is impermeable as long as the water falls on it and drains off into a drain pipe. Suppose the drain pipe of the roof gets clogged, then the water gets ponded on the top. And if you have a ponding of the water on your roof for a day or two, you find wet patches coming under the roof. So that means though concrete is impermeable, supposedly so, it means that it has low permeability, but it has some permeability. So if my leachate is going to remain ponded on this impervious material, say for a month, then I have a problem. It will leak. So I have very few materials which will not leak. Maybe we will discuss this what kind of material we should use, but be ready to answer all these questions. If I use a metal sheet, an aluminium sheet, what is the most impervious material and will it leak or not? You can use concrete, bitumen, clay, we'll discuss that. But it all leaks. So this is not a solution. We need a drain pipe. So we need an impervious material which will not immediately allow the leachate to go down, but whatever accumulates on it, we want it to run away. So in a conceptual form, can I have a drain pipe below? You can only have a drain pipe if you are on the roof, na? Because then water will flow down by gravity. But if you are below, then what will you do? You have to pump it out. There's nothing else you can do about it. So I didn't ask you to dig and go below. You did it yourself. You said, I want to store a lot of waste. I have only this much area of land, and let me go and put the waste below the ground. I never asked you. You could have put it above the ground. You could have made a multi-storied building and put waste in it. I'm just saying that what are the alternatives available to us? So I need to put in a straw or a pipe which will then remove this leachate as and when it is accumulated. So it's just remember your bathroom floor. You take a bath, does the water remain on the bathroom floor? Do you have a pond of water? Why? Because it all goes to a drain pipe जब वो drain clog हो जाती तो क्या होता है? You are using the shower at the top and your feet are now coming under water. And then you know, oh, drain pipe is clogged, we got to clean it up. But otherwise, is the floor of your bathroom horizontal or is it inclined? Is it inclined in one direction or two directions? Two directions, because one direction can only take water from one side of the room to the other side, but it has to go to a corner. So there's a double inclination to your floor so that all water will go to the corner which has the drain pipe. So you have to build something like that. All the water should come to a corner. You should be able to send in your straw to that corner and pick up, and there should not be anything left on the top. So if you have a nice bathroom floor which is dry when you go home, then you like the builder. But if you have a bathroom floor which has got a small negative slope, that means 80% of it is dry, but in the corner there's a wet patch. You know what kind of a builder was it? Right? And we don't want that wet patch, because eventually that wet patch will leak. So we want a beautiful floor where everything runs off to the corner. That's critical to a good design. We are very happy, but what starts to happen is that there are reactions taking place inside the waste, and gas is forming, biomethanization is taking place, anaerobic reaction, methane is formed, carbon dioxide is formed. So like a balloon, when you have put an impervious thing at the bottom and you have put a impervious thing at the top, and like a balloon, your waste begins to bloat up. And I tell you, methane is very explosive. And every now and then, sometimes there are explosions in sewer lines. Why? Because methane gets fire. Okay. So I don't want this methane to bloat up. So what will start to happen is, it will want to come out from this pipe. But this pipe is for leachate collection. It's under the sump, which is always under the leachate. So this doesn't work as a gas release chamber. So I have to put another straw, more like a vent. So I make a vent at the top so that the gas can. And I'm not allowing the gas to escape. I'm collecting the gas. See, the leachate which I'm going to pump out, I can't put it into a drain because it has contaminants in it. Similarly, the gas which is coming out, it is a greenhouse gas. I can't let it go. So I collect this. I allow the emissions to come out along controlled pathways. Please understand, this is critical to the design. I must have pathways. The emissions should go towards the pathway, and I should be able to collect it and then later do whatever I want to do with that. I want to treat the gas, I want to flare the gas, I want to recover energy from it, I want to treat the leachate, whatever I want to do, I want to recirculate it, I should be able to collect these things. So this is good. So far, now I think I have a nice representation of what we want to do, or is there another alternative of handling this? Let me finish this first. We'll tell you what I think, then we'll all discuss. We'll go back to your kitchen and see how you handle your waste in your house, and then we'll take the simile from there as well. After I've done this, I need to ensure that whatever water falls on this, it runs off. It doesn't remain at the top. Let me explain. This waste is biodegradable. It will eventually settle, right? And what will happen to the cover? The cover will become like this. It will become, at the moment the cover is convex upwards. If the center of the cover begins to settle with time, and you know settlements can be pretty large with municipal solid waste, 20 to 30% of the height. So that's a huge amount of settlement. That's not the settlement of soil, because biodegradation reduces the volume of products. So it's possible that this cover will become like this. It will have a depression. Now if you have a depression at the top, it rains, and if it rains, it will pond. So you have to maintain the convex shape. That means if it settles, you have to fill something. And secondly, you have to have an efficient surface runoff system. And this is very important. This is like, you know, trying to keep your cricket field dry when the rains are coming. You want your one-day match to start or 2022 start. So he says 2 hours delay. After that the pitch will be dry. So you say, मेरे को देना था काम, I would have made a pitch which will dry off in 1 hour. Why? I'll put more drains underneath. सारा पानी नीचे ही जाएगा, नीचे gravel drain लगा दूंगा और बाहर निकाल दूंगा पानी. ये नहीं कि water should come from one end of the field to the other end of the field traveling hundreds of meters. So the issue is still the same here. I must have a system which allows the surface water to drain off as quickly as it falls on the top. It's like the roof. It should be inclined. There should be no ponding of water. So we have a surface water drainage system. I just want you to understand that this horizontal width, what do you think is the size of this horizontal width? It may be a football field or 2 football fields. So you may have to put in a lot of drains, intermediate surface water catchment drains to make this water run away. And finally, I don't want my cover to erode. You say, अच्छा sir, हम soil लगा देंगे उसके ऊपर. But soil will start eroding every time it rains because now you've got a convex sloping shape. So therefore you need vegetation. So you need a erosion resistant cover. You need a cover which is has vegetation on it. Or you need a cover which doesn't erode. So that in essence is what is the principle of a landfill. Now let's discuss it. Can we do something better? Remember that this can we do something better? The waste that we are getting has all the recoverables removed from it. Right? So let's not say can we reduce it or make it vanish. I'm only talking about the 30% waste or 40% waste which is coming. Can we do something else to this? It's open for your suggestions. This is one way of doing it. This is some kind of philosophy. So you think you can do something else? Well, let me put this in perspective. You have a dustbin in your house, in your hostel room or whatever. So there's a strike by the Karamcharis. There was one strike in East Delhi Municipal Corporation. It was coming in the papers, right? You remember? But this strike is special. You can't throw the waste outside your house. So the guy is not going to come for the next 1 month. So let's see what solution, because that is the solution we'll adopt for the landfill. You are living in a house, every day you are eating, you are doing the cleaning of your house, the sweeping of the house, the repair work. So for 2 months, the person will not come to collect the waste. You can't throw it in a bin because the big problem. What will you do with the waste for 2 months? After 2 months, somebody is going to come.
Compress it and store.
Wonderful. So you will compress it, you will form a cylinder and put a piston, and every day you will compress it. You will compress it, some liquid will come out, you will put it on the drain. ऐसे ही है ना? ठीक है. So he will compress it and store it. Store it, I don't know how. अब आपने you have compressed it, now here is the waste. क्या करोगे आप इसका?
Plastic bags.
Plastic bag. So he's got a plastic bag in his mind. Pretty good. Plastic bag को फिर आप क्या करोगे? मैं छोड़ दोगे बाहर, दरवाजे के बाहर, कुत्ता आएगा, your dog will come and it will scratch the bag and start eating the stuff because you had very nice non-vegetarian yesterday and all the end products are lying in the bag. If not the dog, the cat will come. And so what will you do with the plastic bag?
Some isolated room.
So you will dedicate now one of your bedrooms for keeping the waste. So what else? I mean, you are living in a 1-bedroom or 2-bedroom flat and nobody is going to come to collect the waste. So what are you going to do about it? No, at least you'll do something about it. That's one of the ways you can do about it. That compact it, put it in a plastic bag. Let's not compact it, let's put it in a plastic bag. In the plastic bag, you'll see after some days some black liquid at the bottom. So you're not so sure that your plastic bag is designed to be waterproof enough for a month or 2. So you'll put 2 plastic bags. You don't want the leachate to come out and you don't want the smell. I am very sure you don't want the smell. Isn't that right? Then Professor Datta has told you that after 1 month that bag will become, because there will be gas inside it. Any other thoughts?
Waste can be used for vegetation.
Sure. So if you have a lot of plants in your balcony, which several of us don't, then I can use it.
Can clean all the plastic bags and just milk cover and all. Just clean
No, no. First, we are having everyday's garbage. So you are wanting to use all the garbage in your plants is too much. Even if you have 10 pots or 15 pots in your balcony, after some time they'll fill up. You can only use this as an addition to the soil, not to replace the soil. So yes, she's back to minimizing the waste. She's back to using the waste as compost, as whatever purpose. You can have a composting plant in your house. You can have a biomethanization plant, I'm told, at a very small level in your house. So we're still with the plastic bag. Any other solutions? The more I think about this plastic bag, this diagram is also beginning to look like a plastic bag to me now. You said niche, there's a liner at the bottom, there's a cover at the top. Just think of it as a huge plastic sheet, so it becomes a plastic bag. Is that what it is? Yes, it is. So if you don't get waste pickers to your house and you can't throw it out of your boundary wall, you'll put your waste, you don't want to smell it, you'll put it into a thickish plastic bag or 2-3 plastic bags, and you'll close it from the top, and if there's an issue of the gas coming out, you'll put a straw at the top, but then you'll put it in a pipe which is outside your window, and you'll put it in a drum. I mean, suppose every day I am using, is this all right? Is this enough waste coming out every day? So I need to put 60 such packets, and I have to keep, so I won't use a full room. I'll buy a big drum, you know, a plastic drum, so that the dog can't come, and I'll put it into it, and there'll be a pipe which will be, so I'll have one plastic bag, then a second plastic bag, then the plastic drum outside it. That will take care of the leachate. I'm sure it won't come out. And I'm bothered about the plastic bag having a lot of gas. First, I'll wait and see whether in two months is a lot of gas going to form, or only Professor Datta was giving some wild theory that it will form. It may take longer. So I don't know how fast the processes will be. Are you in a cold climate? Are you in a wet climate? Are you in a hot climate? Definitely in hot climate, processes will be faster. So if there are issues of that, then I'll have to put a straw so that the gases, or I'll have to open them periodically so that the gas is extinguished. Otherwise, I just put it into a lot of plastic, a lot of impermeable. I'm isolating it from the environment. Is there another solution? So when we have another solution, we will look for it. Till that time, this is the only solution that we have. This is the only, we have to convert it into engineering. This is all philosophical. This is principles. So the difference is, you have a small plastic bag, I have a big plastic bag. How big is my plastic bag? 1 kilometer wide, 1 kilometer long, 40 meters high, and that's my plastic bag. That seems like a very huge plastic bag. Can you build one with no leakage? That's the challenge. That is the challenge. So you can do micro-encapsulation in small plastic bags and put all the small plastic bags in a big landfill and say, all right, my plastic bags won't. Or you can have one big plastic bag. But let me tell you, the surface area of a big plastic bag is less than a lot of small bags inside a sphere. So therefore, the economic solution is to have a big bag. It's not of plastic, it may be made of soil. For all you know, it may be made of concrete, it may be made of metal. I have no idea whether it's a Syntex poly tank or whether it is what. But at the moment, it has got impervious things here and impervious things at the top. Let's go forward. If I have old waste, then I am stuck, because in old waste, already the groundwater is contaminated. I hope you can see this line clearly. It's a little thin, but this is the contaminant plume. So in the old, it has been there for the last 15 years. Rain has been falling and pollutants have been going down. They travel very slowly, so they haven't run off from the site. They are still beneath or a little beyond the waste underneath. Okay? So the only thing we can do is, we can first try to prevent any more water going into the waste. So we can put a cover, and then we can try to prevent this plume from traveling in the downstream direction by putting a vertical cutoff wall here and a vertical cutoff wall here. So if you want to look at it in plan, if this is my waste dump, so I am looking at the waste dump in plan, and the groundwater is flowing like this, then what am I saying is, I will cover this and I will put some kind of a cutoff wall here and a cutoff wall here. So at the moment the groundwater is flowing below the waste, and therefore it is carrying the contaminants towards the downstream side, right. When I put this, the tendency is it will bypass the area. So further spread of contamination may be limited. So that is what is the concept which is depicted here, the concept of vertical cutoff walls or vertical impervious walls. Ideally, of course, I would like to have a impervious layer at the base of the contaminant plume as well. However, it is very expensive. It can be done, but this is a solution which is normally not possible. So what we try to do is, we try and take the vertical cutoff walls to as deep as an impervious layer if there is one at the bottom. Otherwise these are hanging walls, doesn't matter. So typically the solution takes this form. If you don't have an impervious layer at the bottom, I put the vertical cutoff wall here, I put the vertical cutoff wall here, and then I pump out this contaminated plume using a well. So the idea is, I reduce the water level inside these walls, and therefore I don't allow anything to travel out. This is called pump and treat methodology. Put a cover, amount of leachate being produced is greatly reduced. Put cutoff walls, the flow of the groundwater beneath the waste is reduced. Pump out the contaminated plume and treat it and re-inject it so that you get the fresh, good quality water back into the soil. And at the top you have to do the same measures. You still have to have a gas collection system, you still have to have vegetation so that you have a cover which is not eroded with time. So that is the concept of control for an old waste dump. The peculiarity is that instead of having a liner, you need a vertical cutoff wall. So what we have said so far in terms of philosophical term is, to reduce the environmental impact, we should isolate or contain the waste in an impermeable barrier. That's the philosophy that we have said here. You don't like it, we are ready and open for another philosophy. But at the moment, that's the only one we've got. Actually, we would like to homogenize things. We would not like to encapsulate, separately. But once you try and homogenize waste into the soil, you will be passing on the contaminants into the soil. So at the moment, it is isolate or contain the waste. Do remember that no matter what material I make, including this very beautiful membranes of polymer, infinite isolation is not feasible. Good barriers perform well for 50 to 100 years, but cannot last 1,000 or 10,000 years. So we don't have a material which will last for geological time frame. Just look at your grandfather's or great grandfather's house. They made it out of concrete or brick or lime and surkhi and what, but they thought they were building a house for 100 years, but that's about it. That house is not going to stay for thousands of years. What we see which stays for thousands of years are these old forts. Now how come they stay there for thousands of years? They are not made of concrete, they are made of rock, segments of broken pieces of rock. Rock is a material which will stay for thousands of years. It's been made over a long period of time. And basically what will happen, the jointing material will fall off. So even in the old forts, what is falling off? The rock segment remains unaffected, but whatever was used as the joining material, that peels off with time. So infinite isolation is not possible. So we again come back to this diagram, which is what we were not happy with. We don't want this. I don't want to be next to this dump. And this is the concept. This is the concept of landfilling. You put a flexible cover or a barrier at the top. You put a flexible barrier or a liner at the bottom. Nothing can come in, nothing can go out. So no leachate, no surface water contamination. Collect the leachate by a set of pipes. Collect the gas at the top, the set of pipes. It doesn't affect the immediate environment. But as I said, after 50 to 100 years, these barriers will not perform as well as you have designed them, and by that time the waste should either be stable, or we are just looking at this as a temporary placement facility. So this is the solution for existing old waste. And if you can get an impervious layer at the bottom, then the vertical cutoff wall should reach the impervious or a clay layer at the bottom. The important thing to see is, and I go back, we are looking at this first. This is what it is conceptually, and this is the engineering. See, the cover is made up of multiple layers, and we'll come to that in the detailed design. But the cover and the liner are made up of multiple layers, and these multiple layers are required for containing the waste and preventing the spread of contamination. So let me try and articulate this. If you put a waste in a scientific or an engineered manner on the ground, you create what is called an engineered landfill. Now the engineered landfill will have 1, 2, 3, 4, 5, 6, 7 components. 1, 2, 3, 4, 5, 6, 7 components. It will have a liner system, an impermeable base, so a liner system at the base and the sides of the landfill, which prevents migration of leachate or gas to the soil. So it's impervious to water, it's impervious to gas. Methane, if it not being allowed to go upward, should not be able to go sideways as well. It will have a leachate collection facility. I showed you a straw, the straw which takes out the leachate. It has a leachate collection facility which collects and extracts the leachate from within and from the base of the landfill and then treats the leachate. So the leachate has to be handled in some manner. Where will this leachate go? How will you treat it? But there are several options, but it has to go to a treatment facility. We need a gas control facility which collects and extracts the gas from the top of the landfill and from within the landfill, and it treats this the gas, and it may flare. It means you've got a gas which can be burnt. You burn methane, you get carbon dioxide. The greenhouse gas effect of carbon dioxide is much lower than methane, so you may flare it, or you may use it for energy recovery. So you actually can have a waste dump from which you put in some pipes, the gas is coming out, and you can have a small thermal power plant where you'll burn the gas and get electricity. And that's happening at several locations in the US. Then I have a final cover system which prevents migration of gas. Gas will not come in your pipes if it is not prevented from escaping from the surface. Suppose you don't have a cover at the top, the gas can go out. So first you have to constrain it in a balloon effect, and then its pressure will make it go into the gas control system. So a final cover system which prevents migration of gas to the atmosphere, enhances surface drainage. That means your cover system has to be convex upwards, intercepts the water, doesn't allow it to go into the waste, and supports surface vegetation. So it's not all that simple. You want a facility which looks green. Typically, you don't want a concrete finish. Why? This is aesthetics issue. You have these are relatively big mounds. So when you see them from far off, people are not happy with the gray finish. They want a green finish. So therefore, you can't have a black membrane like your black plastic bag, and you can't have a concrete finish which is gray. So you have to have a surface finish which will then allow you to grow a layer of grass or the local vegetation of that area on it. Other than these four, we need a surface water drainage system. So there have to be a lot of drains which will collect all the surface water falling at the top and take it away. We need to have an environmental monitoring system. At least we should know when the landfill is leaking. I mean, we are putting all the waste in a concentrated location. We should monitor it that the contamination doesn't travel beyond the boundaries of the landfill. And so detect leakage early is one of the concepts for this environmental monitoring. And finally, we should have a closure and a post-closure plan. You take a site in which I can accommodate the waste for 25 years, right? I get 2 football fields or something, maybe more, and I find that I can accommodate my waste for 25 years, and after that, the site is closed. While the waste is coming, it's active. There are trucks, there are dozers, there are excavators, there's earth moving equipment, there are people who are maintaining the site, the pipes, the drainage systems, and finally it's all over. No more waste will come. Site has to be abandoned. So if you can't walk off a site because you still got the waste in there and you're not sure it's stable, it's still producing some contamination. So you need a closure and a post-closure plan. What is going to happen to the site after you walk off it? Are you going to have a golf course on it? Are you going to have a parking area on it? Can you put buildings on it? Intuitively, the answer is no. It's a soft settling mass. So you can't put buildings on it. But you can use it for some other purposes. So you must make a closure and post-closure plan. That means how are you? Once you've got a closure and post-closure plan, then you can work out your maintenance costs. Suppose you're making a public park. People can come and you've controlled your gases, you've controlled the smell. People find that this is a huge open space to come under supervised monitoring, they can come. So, and the revenue that you can generate from that can help you maintain the site, because you have to keep your leachate systems going, leachate collection systems, gas collection systems going, surface water drains. If the surface is settling, you have to set it right. So need a closure and a post-closure plan. These are some of the options for landfilling. I can dispose the waste above the ground and below the ground. So this is all disposal on the ground surface. I can excavate and dispose it, or I can dispose it above. Is there a question? You can have a combination of both. That means you can also have a waste which is going above. So the idea is, where land is limited, you want to maximize the amount of waste that you can place. How deep below the ground can you do an open excavation? Yeah, so eventually you will hit groundwater table if you have groundwater. So that's one factor, that you cannot go much deeper than 2 meters above the groundwater table level. Suppose the groundwater table is deep below. How much can you excavate? Well, typically we like to do unsupported excavations. I'm not going to do a 20-meter deep excavation which will require sheet piles and vertical walls. So we will have normally somebody may excavate, I've seen it happening, 7 to 8 meters with sloping ground. 7 to 8 meters is like 2 basements. Like 2 basements, right? And then above it. Can we dispose of deep below in cavities, in rock, or not? Well, let's look at this. So please understand that excavations like tunneling and putting the waste in it are very expensive. Putting the waste in soil beneath the groundwater table is not allowed, because this is a totally saturated medium. But in strong rock, you may have to dispose some very toxic or hazardous waste like nuclear waste. So we are disposing nuclear waste, say 2 kilometers below the ground surface in strong rock, because strong and competent rock will not have water and will have a lot of strength to be able to bear any of the unusual stresses which might get induced because of the waste. So really we can dispose above the ground, just below the ground, or deep below in strong rock. Above ground landfills have the following advantages. Leachate will come out by gravity, like it goes off your bathroom floor. You don't need to put on a pump. Leachate, that's a big advantage. And there's a large thickness of unsaturated zone beneath the landfill. That means it has a lot of holding capacity, right? And therefore you are well away from the water table. Poor surface drainage can be avoided. You are higher than the ground, you can make a convex shape, there is no issue in it. And all the surfaces can be inspected except the bottom. All the surfaces can be accepted except the bottom. But the disadvantage of above ground landfill is you have altered the land use plan. There was a horizontal ground, you made a mound on it. More surface area is exposed, the top is exposed and the sides are exposed. The top is exposed and the sides are exposed. So because more surface area is exposed, there are issues of slope stability and erosion control. In a below ground landfill, what is exposed? Temporarily the side surface areas will be exposed during the excavation and placing of the waste. But after that, only the top is exposed. So there is no slope above the ground. So the disadvantage is here your slope will remain there for the entire life and the post closure period. So more surface area exposed and slope stability issues. Advantages of below ground landfills? Well, if you have below and above ground, more waste storage per unit area. Excavated material can be used as covering for covering the soil. Parks, golf courses, parking lots can be developed on the finished area. That means the finished area is not very high. It's at the same level as the ground, so you can make a park or a parking lot or a golf course. And long-term slope stability issues are not an problem. While the facility is under operation, you may have a slope stability issue, you have a heavy rainfall, but after it's closed, then the slopes have got waste on top of it, there's no issue. The biggest problem is that you can only bring out the leachate by pumping. So you need electricity and your pump should work when you put on the switch. So we need regular pumping for leachate collection, that requires external power, and good surface water drainage is required. You know, if you finish the surface of the below ground landfill at ground level, it will settle with time. Then there is a tendency of water to pond over it. The water from the adjacent areas can also come onto the low-lying areas. So either you should finish it a little above the ground or you have to have excellent surface water drainage facilities. So let me summarize this. For very toxic waste, you can dispose it deep below in rock. This is usually applied for nuclear waste. Otherwise, hazardous waste landfills and non-hazardous waste landfills are near the ground, either above the ground or below the ground. You cannot go below the ground in two cases: when the water table is very close to the ground surface, and second case, when there is rock near the ground surface, because excavating in rock is exorbitantly expensive. Otherwise, one tends to dig a few meters and make a below ground or a below ground and an above ground landfill. So these are the three options. Now, what types of landfills do we normally deal with? We have hazardous waste landfills which deal with most of the industrial waste which is coming out from processes. We've already talked about it. And we have non-hazardous waste landfills which deals mostly with municipal solid waste coming out of a facility. And we have inert waste landfills, where the word inert is always to be understood in the context of construction and demolition waste. So these are typically the three types of landfills which are available or should be available in a city. The inert waste landfill for construction and demolition waste is virtually a temporary storage facility, because you will be recycling your construction and demolition waste after processing it. But other than that, you may also have monofills for high volume waste. If only one type of waste is coming out in huge quantities, a thermal power plant will set up several thousand tons of waste per day. It's only ash. So you can have a monofill, that means a single in one single area, only one type of waste. Municipal solid waste and industrial waste will be pretty heterogeneous with different sources. Ash ponds and mine tailings ponds are monofills for high volume waste. And then, as I said, there are special landfills for highly toxic or radioactive waste. And there are two configurations. We have already talked about this again. All the landfills can be at one location. The municipal landfill is the biggest. You can have construction waste landfill and the hazardous waste landfill. But the maximum waste comes here, right? This can be one facility. It can be monitored very closely and very accurately. But if the distances are very large, then you can have the three facilities set up separately. You can have one landfill for municipal solid waste, which gets the mixed municipal waste, the waste processing rejects, even the industrial non-hazardous waste will come here. Because if you send the industrial non-hazardous waste into hazardous waste landfill, it's very expensive. The hazardous waste landfill has got more stringent measures for environmental protection. So C&D waste can go to a separate landfill, and hazardous waste can go to a separate landfill. So with these two configurations, let's spend the next 3-4 minutes on the landfilling philosophy. What have we said so far? So first aspect of landfilling philosophy is only that waste should be placed in landfills which has no recoverable component. Do not place any material in landfills which has a recoverable component. If it has to go to the appropriate processing unit. Landfills that we are talking about are called dry tomb landfills. These are impervious at the top, impervious at the bottom. These are called dry tomb. You don't allow any water to come inside it. So they are not designed like bioreactors. You'll hear of a term called bioreactor landfill, and we will discuss it in the next class. But you should remember that if you have a biodegradable waste, it should be sent separately to a biodegradable waste processing facility. The landfills that we are discussing here are dry tomb landfills, where all biodegradable waste which was reutilizable has gone to a composting or a biomethanization, an anaerobic or a aerobic composting plant. The design of a landfill is typically 50 to 75 years, the same as is for this building. Beyond this, the containment barriers may not perform satisfactorily. Now, the impervious material, if it is metal or if it is polymer, the manufacturer may say this will last for 300 years. That's not important. When you join these metals along joints, then the joints may fail after some time. So it's not about the parent material. It's the total system. How does it perform? It will perform to 50 to 75 years. Now, if the waste stabilizes within this 50 to 75 years, after 75 years, if you dig up the waste and there are no contaminants in it, whatever had to wash out has washed out, has gone out with the leachate, or whatever had to degrade has degraded and the gas is no longer being produced, that means the waste is stable. Then it can be harmonized with the environment. Then this waste is in its final resting place. However, if after 50 to 75 years it still has contaminants, the leachate shows it still has contaminants, there's still gas emanating from it, then this is only temporary storage. And what will you do after 50 to 75 years? If it is temporary storage, what will you do after 50 to 75 years? Or you'll do exactly what you did to your grandfather's house. What did you do to it? You broke it down and made a modern new house. So similarly, you'll have to excavate this whole material, put in new liners, unless technology has changed in 50 to 75 years, which it might, and you have to reline the system and put the material on top. So, we have quickly captured the principles of landfilling. Now, there are many alternate schools of thought in environmental engineering on how you should handle solid waste. This is one of them. You think there is another way? We will be open to have detailed discussion on how to handle waste the other way. One of the terms you will hear a lot is called bioreactor landfills. So, you have a little assignment which has to be submitted by Monday. Please write a paragraph on what are bioreactor landfills, and please tell me in how many countries are they being used extensively. Okay? Just get an idea. So, how many countries are bioreactor landfills being used? So, that will be the opening discussion that we will have in the next class. In the meantime, if you have any questions, any clarifications, I am happy to.
So when is this final cover put?
Question being asked is, when is the final cover put? And it's a brilliant question, because if the landfill is designed to be operative for 25 years, are you going to put the cover after 25 years? So, no. We operate the landfill such that we put a part of the cover every year. So, suppose I have a very long 1 kilometer landfill, then I am not going to put the waste 1 kilometer. I am going to put the waste suppose it is going to be filled up in 20 years. So, I am only going to put the waste in 1/20th of the 1 kilometer, and I am going to raise the waste to its full height in that one. And at the end of the year, before the monsoons come, I am going to put the final cover. The next year I am going to move forward. So, the fundamental mistake which many people make is they make a huge landfill. We get funds under JNNURM for our landfills, and people have got funds for 5 years of landfilling, 15 years of landfilling, and they made these huge landfill bases. And once they made this huge landfill bases, now you start filling it up. And it is absolutely wrong to fill it up in horizontal direction. You are supposed to make small phases and finish the phase to the full height and then cover it and then go to the next. That is the only way you can get less leachate, and that is the only way you can prevent a lot of infiltration into old waste. If you spread it out, even if you are doing it over 5 years, you are getting 5 monsoons falling on your waste, you did not operate a landfill well.
So are these modules interconnected, or they have separate like leachate system and the gas connection?
So the intent is to have interconnected, incrementally increasing landfill area. So they are interconnected, they are a part of a grand plan. If you don't make the plan phase plan correctly, you got it all wrong. So the question is, when do we put the cover? We don't put the cover after, if you have a landfill for 20 years, you don't put it after 20 years, you put it every year. And the second question is, if every year I am operating a phase of the landfill, are these independent phases or do we connect them? If I make them independent phases, I lose a lot of airspace. That means where I can put the waste. So when I put the next phase, it is integrated with the earlier phase, and therefore all the systems are also integrated. The cover is connected, the leachate collection system is connected, everything gets connected. Any other thought on or clarification on? Right, then we will stop here and we will start next time, and we will all like to understand what are bioreactor landfills and how great are they. Right? Thank you. Have a good day.